By the way, just as a side discussion, those of you who are in campus, can you please raise your hands? Okay, very good. So, yeah, so stay safe, I think. Okay, so let us start. Let us start the discussion because we have to cover a lot of the things. Okay, and maybe others will join. Okay, so just to sort of recollect, we had discussed two things in the last class. I mean, we had started discussing function overloading, but we had discussed the default parameters in C++. Okay, and as we shall see, these are kind of, you can think of them as also related. Okay, but so the key idea behind default parameters is very simple, that at the time of declaration, you can make some of the parameters of a function. You can assign default values to some of the parameters of a function. And there are some rules. So basically, at a high level, what you should try to do is you should make the rightmost parameters default. Okay. So this is number one. And then you can actually further redefine a function with, so whenever you assign a default parameter to a default value to a particular parameter, what you do is you effectively, I mean, in your mind at the time of implementation, what you can think is you're effectively creating another function. Okay, where so like for example, you can see that. So for example, let's say mm, you are so you are having this add function where you are saying that you have assigned default values to A and B. Okay, so what you can think is in your mind that you are creating. So your original function is this first function, which is add, which should be called like add x comma y. But you are also creating this add x function and add function, which are basically like saying, so you are defining it as though add int a10. Okay, and then that's all the parameter there is. And here, instead of b, you just write 20. Okay, so that is a very simple way of looking at it. Okay, without going into the implementation details of it. Okay, so this is one thing. Okay. um, okay, and the utility is very clear. Now, what there was a discussion about this. So Hello. Can you hear me?
Yes, sir,
Hello.
you are
Yes, sir, you
audible.
got
Yes, sir.
disconnected.
Okay. Okay. Yeah. So some sorry, I got disconnected. I think there was some network issue. Um, okay. Yeah. Okay. Yeah. So we had this discussion that if you let me okay, let me come here. Yeah. Yeah. So in this slide, in this particular program, actually, yeah. Yeah. Yeah, so in this particular program, actually, okay, so we had this discussion that you can default one parameter, okay, and then you can then you can again redefine or rather redeclare, okay, the same function with another default value. Okay, so here we are we are defining the last parameter as default. Okay, and here we are declaring the second parameter as default, but the defaulted value for the last parameter is also taken here, even though it is not explicitly mentioned here. So it is borrowed from the previous declaration. Okay, and so on and so forth. So then it results in all these different versions of the original G function. Okay, so these are the two things about default parameters. Okay. Now, then what we did was we went into function overloading. Okay, so function overloading is slightly different. Okay, here what we are saying is that we actually define different functions. Okay, so remember in case of default parameters, there is only one definition, function definition. It is just that some of the values are getting or some of the parameters are getting default values. Okay, but in case of function overloading, okay, what happens is you actually define multiple functions with the same name. Okay, but their parameter types are different. Okay, and basically the compiler decides which function to call, okay, based on their parameter type. Okay, so this is one part. Okay, now and we have seen the example of this matrix multiplication. Okay, but as you can understand, there can be many different applications of this particular feature. Okay, yeah. Uh, yeah, so by for the function overloading part, so when we say binding, so here binding basically means binding a particular definition of a function to a particular call. Okay, so when you are binding a particular definition of a function to a particular call, then basically this, in case of function overloading, this binding happens at compile time. Okay, so at the time of compilation itself, the compiler decides that which particular definition of the function to use. Okay. Okay. So okay. Now, yeah. So like we discussed last time, the other thing is that two functions having the same signature but different types cannot be overloaded. Okay, so if your signature is same but the return type is different, okay, this is not a valid function overloading. Okay, only if you change the types of the parameters, that is a valid way of overloading functions. Okay. Okay. Now, okay. So the
Sir,
yes.
Sir, when we change the return type as well as the type of means the order or the type of parameters, then is it still function overloading or is it like a new function has been created?
It is still function overloading. So if the name of the function is the same, okay, but there are multiple definition, then you are using a function overloading.
Also, sir,
Okay, sir.
here in double area, double A, double B, we can do this like.
Yes, so you can do double area, double A, double B.
Okay, okay, sir. Thank you, sir.
Okay. Okay. So now, okay. Yeah. So just to summarize the rules, the same function may be used in the same function name may be used in several definitions. Okay. Functions with the same name must have different number of formal parameters and or different types of formal parameters. Okay. Uh, Function selection is based on the number and the type of the actual parameters at the places of the invocation. Okay. So, okay. Function selection, which is called overload resolution, is performed by the compiler. Okay. Um, yeah, so two functions with the same signature but different return types will result in a compilation error due to yeah, so attempt to redeclare or it's a redefinition of the same function. Okay. And overload, as we discussed last time, overloading allows static polymorphism. Okay. Now, a key problem here is that when you are using a function, okay. Yeah, there is somebody. Can you please mute? Okay, thank you. So see, so like we said that the compiler at compile time decides how to overload the how to resolve the different overloads for a function. Okay, so so it is important for you to understand as a user of function overloading. It is important for you to understand how this resolution is performed, because then what you can do is, given multiple overloaded function definitions, okay, when you are making a particular call, okay, you can figure out which of these definitions will be used. Clear? Okay. So what is the overload definition or overload resolution procedure? Okay. Okay. So the compiler uses three stages, broadly three stages to uh, do overload resolution. Okay. Um, okay. So okay. Uh, so now, okay. So first is, it identifies a set of candidate functions. Okay. Okay. Then, and we'll see each of these stages. Okay. Then the second stage is, it identifies a set of viable functions from the set of candidate functions. Okay. These viable functions, you can say, are uh, you know all of them could have been called in this particular case. Okay, not all candidate functions can be represented with or can be called at a particular can be. Okay, so let's so it not all candidate functions can be bound to a particular function call. Okay, but all viable functions can be bound to a particular function call. Okay.
Sir, can
And
you say what is candidate function and what is viable function?
yes, so I will just come to it. Okay. And then the third stage is that you select the best viable function. Okay. from this, and there is a procedure. We'll come back to this. Okay. Okay. So what is the candidate function? Okay. So candidate function is basically just a match. Okay. So candidate functions are selected by the name of the function. Okay. So for example, let us see this example. Okay. So if you have a call here, let's say F 5.6. Okay. And you have many different function definitions here. Okay. So yeah, so you have the prototypes here, but let's say you can have definitions for all these functions. Okay. So you have this int G double, you have void F, okay, then void F int, then double H void, okay, and so on and so forth. You can see the function definitions. In particular, you can see that there are three definitions or three prototypes for the function F here. But actually what you have is, there are four prototypes for the function F here. Okay. But you have in one of the prototypes, you also have one of the parameters being defaulted. So actually this function F can be called in 5 ways. Okay. So it can be called without a parameter. It can be called with an integer parameter. Okay. It can be called with one double parameter or two double parameters. And then it can be called with one character type parameter and one char star type parameters. Okay. So we will see it can also be called in different ways, but we'll see. Okay. So at the time of resolving this particular call, okay, first you find the candidate function. Okay. So what are the candidate functions? So all functions with the name F. Okay. So F2, F3, F6 and F8 are candidate functions. Okay. So this is the first step. Okay. Next, you find out all the viable functions. Okay. So viable functions are those functions, okay, which are which are viable in this particular function call. Okay. And this is decided by the number of parameters. Okay. Number and type of parameter match. Okay. So so what that means here is that basically we are seeing that F3 and F6 are viable here. Why is F3 a viable function here? Because there is a one argument, okay, and here there is an argument of type int. Notice that here the argument type is not matching. Okay. So 5.6 is of type double. Okay. But this is still a candidate. Okay. Okay. And now F6 is also a candidate because you remember that F6, this definition can be called with one double. Okay. Because the second parameter is defaulted. Okay. So these are the two viable functions. Okay. Now, the third step is to find the best viable function. Okay. Now, this is an important step. Okay. So now, so we will come to how the best viable function is arrived at. Okay. So there are four ways to find the best viable function, and this resolution is performed sequentially using one of these ways. Okay. So what are the four ways? The first one is exact match. Then there is a type promotion. Okay. Then there is a standard type conversion. Okay. And then there is a user defined type conversion. Okay. So you can see that the best viable function can also be found through standard type, some kind of type conversion or type promotion. Okay. So hence the call that, at the time of the call, the type of the argument and the type of the declared function need not match in order for function to be viable. Okay. Okay.
Sir, can you
Now
explain what is promotion again?
we will come to. Okay, we will come to. Huh? So what is exact match? So these are the ways you can do exact match. Okay, so what are the ways you can do exact match? First is L value to R value conversion. This is the most common way of doing exact match, which is that if there is a variable of a particular type, you basically, it's an exact match to the R value of that type, okay, or to the formal parameter, okay. Second is array to pointer conversion, okay. So basically, what you can do, you can call, if you have defined an array, you can directly call it as a pointer, okay. So this is considered to be an exact match, okay. Function to pointer conversion. Okay, so again, same thing with function pointers. So if you have a function pointer as an argument, okay, you can, yeah. So basically, you can just give the function as the function pointer argument. Okay. Yeah. Yeah, and then qualification conversion, of course, that you can supply const pointer, okay, with a pointer type. This is also considered to be an exact match. Okay, so these are the exact matches. Okay, now
please explain the function pointer once more.
So suppose you have this function f which takes an integer as input and a function pointer as input. Okay, so then okay, and now basically what you can do is you can supply the function name as, so the function name serves as the function pointer here. So this is an exact match. That is the function to function pointer conversion. Okay.
Also,
Okay.
sir, I am unable to understand the type def statement.
Okay. So this is basically you are just defining a function pointer. Okay. Okay. Yeah. So you are defining a function pointer fp, which is a function, which is a pointer to a function with an argument int, okay, and a return type int. Okay, so this is defining fp as a type of function pointer with this particular argument, and this particular return type. Clear?
Okay, so FP is the new this int star int.
So FP is a pointer. So the type of FP is basically a pointer to a function which takes an integer as input and returns an integer.
Yes, sir, got it. Yes, sir. Thank you, sir.
So like, why do we need to declare a function pointer, or like, how is it used? Because if we want to call a function within another function, we can just invoke it there. So like, I didn't understand why is there a use to create a function pointer.
Okay. So why do you need function pointers? Okay. So so one of the uses I can tell you is that suppose you want to, let's say you have two versions of so you have an array, let's say, okay, and you have two versions of functionality, okay, and let's say depending on some information, you want to call a particular version of the function, okay. So then what you can do is you can store a pointer to that particular function, okay, there instead of storing yeah, so you can basically store, you can have another array where you can store that particular version of the function. Okay, so basically yeah, so in C this was a way of saying that which function to call should be decided at runtime. Okay, or not which version of the function. So which function should be called should be decided at runtime. Okay, for that you need to achieve that functionality, you need function pointers in C. Is that clear?
Okay, sir.
Okay,
It's the
because
name of the
Sir, there are some other methods also by which during the runtime we can determine which function to call.
there are indeed there are, yes, but using function, yeah, so function pointers are not very widely used. Okay, but yeah, but I mean, this is one of the functionalities. Okay, so you can basically so yeah, you can pass a particular version of the, at the runtime, basically you can, at the call time, you can pass a particular version of the function. So another thing is that again, you can actually what you can do, you can a library designer, maybe this is a better example. Okay, so a library designer can provide okay, so yeah, so actually maybe suppose you are designing a sorting function. Okay, and you want it to be a generic sorting function. Okay, and there the comparison, okay, so your input type can be anything, so type of the elements can be anything, and your your comparison operator also you can define, the user can define. Okay, so that is, so your sorting function would then take the comparison operator as a input, and this comparison operator is now a function pointer. Okay, so this is, for example, one application. Clear?
Professor Shorangshu, may I put a comment?
Yes.
If you kindly permit. Students, very simple. If you want to write a function that takes a function as an input, think about this situation. You want to write a function. We are writing functions always thinking that it takes, simple variables or values as input. But if I want to write a function which takes function as an input, one example Professor Shorangshu has already given. I will give you another example. Suppose you want to write a function which integrates a given function from within two bounds, A and B, like integration A to B or 0 to 1 for, say, sine x, integration 0 to 5 for x square, integration -2 to 3 for 3x plus 2, and so on. I want to write this integration function. Now, in this integration function, there will be three parameters. I need to know what function I integrate. I need to know the lower bound and the upper bound. Bounds are fine. How do I put this input function parameter? That is where I put this function pointer, which is the placeholder for a function. But to write the code for the integration function, I do not need to know which function it is. When I invoke the integration function, I will pass the particular function, whether it is sine x or it is x squared or it is 3x plus 2. I will write that function and pass that function in the place of the function pointer parameter. That is the basic requirement. There are several uses for it in terms of callback mechanisms and so on, which we will come to later on. But the reason we have this is to be able to use a function as an input parameter, or for that matter, you can also have it as an output parameter. You can have a function pointer as a return value, which is a little bit more involved in the concept, but that is the basic reason you have function pointers. Does that make it clear?
Yes,
Okay, yeah,
Yeah.
okay.
Please proceed.
Okay.
Sir, but the functions that you're saying cannot be integrated as you said, right? Like they have their written values.
So suppose you are doing a numerical integration. Okay, so you know about numerical integrations, right? So there are, for example, these mathematical libraries which provide routines to do numerical integration, like trapezoidal method and all these things. You know about those?
Yes, sir.
So there, the same method can be used with multiple functions, right? So the function is provided by the user at the time of the calling, which function they want to integrate. Does that make sense?
Sir, I'm saying that which function, if we select which function to be integrated, but that function needs some variable and it has some written value. So how do we integrate that? That's the thing.
So
If it-
you know about the trapezoidal method?
Yes, sir.
So you can divide the range, the range from lower bound to upper bound into a certain box, certain boxes, and then you can do the integration, right?
Yes, sir. Summation.
Yeah, summation. So and then so what will you need? You will need the value of the function in each of these boxes, right? The median value you will need, right?
Yes, sir. Got it.
Okay, so yeah, so that you can, inside the integration function itself, you can calculate that median value. Okay. Okay, so okay, so this was a bit of a sidetrack. Okay, let us. So we were just to come back to the original topic of discussion. So these are exact match. Okay, now after the exact match is done, and you have yeah. So basically, we are trying to find the best viable functions. Okay, so if there are so if exact match is found, okay, then that is the function that is called. Okay, so nothing else is. So if there is an exact match, then that is the function which will be called. Okay, or that is the function definition which will be called. Nothing else is looked at. Okay, but if if no exact match is found, okay, then the next step is done. That so next step is about promotion. So promotion is the simple promotion. So there's the character to integer promotion, float to double promotion. Okay, then there are enum to int, short, unsigned int promotion. Then there is bool to int promotion. So basically, promotion is like from a smaller data to a larger data. Okay, so these are all promotions. Okay, so there are standard defined promotions. I have listed some of them, but basically the rule is like this, that so for example, from int to long int will be a promotion, and so on and so forth. Okay. Okay. Then
Sir, can it be from int to float?
no, int to float is okay. Actually, yeah, no, I think int to float is not a promotion. Okay, so it's a conversion. So let us come to conversion. Okay, so because int and float, I mean, float is not really a larger version of int. Okay, float is a different representation. Okay, it's not an integral representation, right?
Yes, sir.
So there will be data loss. There can be data loss if you try to convert from int to float. Okay,
Sir, into long, those types.
those things are promotions, right? Into long or into long will be a promotion. Okay, so if a promotion is available, then the promotion will be taken. Okay, if promotions are also not available, then we will take this standard conversions. Okay, and these are basically integral conversions. Okay, so integral conversions is basically conversion from other types to integers. Okay, then floating point conversion, okay, a conversion from other type to floating point types, okay, and then floating point to integral conversion, okay. Then there are pointer conversions and Boolean conversions, and conversions are dangerous basically because they are so at least these three conversions, the top three conversions, are dangerous because they can result in data loss, and yeah, so they can result in data loss, okay. Okay, so this is okay, and yeah, so if okay, so and if there is no standard conversion, then the last thing is user defined type conversion, okay. So if there is a conversion from one user defined type to another user defined type, we'll come to this when we actually come to classes and all that, okay. But this is the order. Yes.
So what is pointer conversion and bool conversion? Like, could you explain, please?
Okay, so pointer conversion is conversion from, let's say a pointer of type int star to pointer of type, let's say float star or void star, something like this. Okay.
Okay, sir. And bool conversion?
Bool conversion is from let's say an integer or a character to a Boolean value, right? So you know that any non-zero value is taken as true and 0 is taken as false, right?
Okay, sir. Yeah. Okay. Thank you.
So, does the pointer promotion also take place?
Sorry.
Does the pointer promotion also take place like the data type promotion?
I'm not able to understand. Data pointer promotion. Oh, so there is no pointer promotion, right? There is no pointer, can only be conversion. All pointers have the same size.
Okay, sir. Got it.
Pointers are addresses, so they have the same size. Okay. Okay. So okay. Yeah. So now in this, let us come back to this example. So we have these viable functions f3 and f6. Okay. And in this particular case with f6, there is an exact match, right? So f6 is called. Okay. Now let us see some more examples.
Sir, can you go to the previous page?
Yes.
Sir, if we have here a void f double, then which one will be called?
Void f double, then which one will be called, right? So okay, so what will happen if you have void f double? I'll come to that. Okay, so let me just come to that. Okay, so it will be an ambiguous call. So it will throw a compilation error saying it is an ambiguous call, and let us come to that. Okay. So what happens when, what results in ambiguity? So that is the next step. Okay. Okay. So okay. So now yeah. So consider yeah. So consider these function prototypes. Okay. So the first one is fun float A. Second one is fun float A float B, and third one is float X and int Y is equal to 5. Okay. Now, what will happen with the first call? Okay, the first call, you are calling it with something that is float, okay, and something that is int. Okay. So for the first case, what are the viable functions? Okay. So the viable functions are 2 because both of these functions, so function 1 and function 2 are both viable function definitions for the first call. Okay. Now, yeah, so okay. Now there is an exact match with the function 3. Okay. So it matches function 3. Okay. So function 3 will be called. Now think about the second call, okay, where you are calling it only with a float. Okay. Now, what are the viable functions? Okay. Function 1 is a viable function. Okay. And function 3 is a viable function because you have a default value for the integer parameter. Okay. Okay. And both of these are basically exact match. Okay. So this results in ambiguity. So the compiler will give an error that this is an ambiguous function call. Clear? Okay.
Yes, sir.
Okay. Now, yeah. So
Sir, I have a doubt in last slide.
okay.
Sir,
Yes.
here we are not able to declare the functions in such type, or compiler does not allow to call the function in such a way.
A compiler is not allowing to call the function.
Okay, we can declare the functions in such a way, like float a and float x
Yes.
int y is equal to 5.
Right. So if you just comment out this fun T line, okay,
Yes,
it will compile fine.
okay, sir, got it. Thank you.
Okay. Okay. So now, we are just looking at. So we first talked about default parameters, okay, but now we are looking at default parameters from a function overload point of view, okay. So so you can think of these default parameters, okay, as defining overloaded version of the same function, okay. So how is it happening? It is basically defining, so it's defining, so left is the default parameter version, okay, and right is the overloaded version of, I mean, which will have the same effect, okay. So basically you define 3 different functions, okay, all with the same name, of course, but different parameter types. So int is where you have int a and int b with no default values. F int is the one where you basically have int a with b set to the default value, okay, and int f with no parameters is where you have the same function definition with both a and b set to the default value and no input parameters, okay. So you can think that this is, so function overloading is one of the ways of, from the user point of view, you can think that function overloading is a way of uh, handling, default parameters. Okay. Okay, but now that sort of raises this issue that, so when you are using default parameters and function overloads in conjunction, okay, the calls should still be resolvable. Okay, so otherwise it will again give a compilation error. Okay, so so let us look at this. Okay, yeah. So suppose these are the 2 definitions. Okay, and in the first definition, the B has a default parameter. So actually there are 3 definitions. One is with area int A, area int A and B, and area double C and D. Okay. Now, what you are doing here, so you are calling with an integer. Okay. So it is binding to the first function. Okay. And here you are calling with the first one as double. Okay. And the second one as integer. Okay. Second argument as integer. Okay. Okay. So which one will it bind, right? Okay. So so you see it will create these so basically there is, so for this one there is no exact match, right? So it has to use type promotion. Okay, so okay, and so it had basically two options. Okay, one is it could do a promotion of yeah, so it could do a promotion of this double. Okay, it's not a promotion, sorry, it's a standard conversion. Okay, so it could do a standard conversion of double to int, or it could do a conversion of int to double. Okay, so in this case it prefers this int to double conversion, and hence it binds to the second definition of the function. Clear?
Like, sir, always it will go for promotion.
No. It is not that always. So this is not promotion, by the way. I'm sorry. This is standard conversion. Promotion means from int to long or int to long, like that. Okay. This is not promotion. This is conversion. So there is going to be data loss. Okay. So this is because no promotions were found. So it went to the third stage of standard conversion. Clear?
Sir, will there be data
And
loss
sir,
from int to double?
Yes, so from int to double, there will be data loss. Yes, but it will prefer that over double to int.
Okay.
also, sir, like it would be float, means instead of double, it would be float. Then also it would work.
Sorry, go ahead.
Sir, instead of double, if there is float, then also it would work.
Instead of double, okay, yeah, yes, it will work. Yes. Okay.
Sir, how do we how do we do function overloading in case means like if there are more than one parameters, how do we resolve the overloading?
If there are more than one parameters, how do we resolve the overloading? Yeah, so that is what I just described, right? So
Yes, sir. So we move from left to right in the terms of variables.
yes. So we move from yes. So sorry. Maybe your question is not clear to me. You are talking about only overloading, or you are talking about default parameter also? In the left to right rule applies for default parameters.
No, sir. I'm saying like we just studied the rules for overloading resolution for only one parameter. So for more than one parameter calls, is the rule same or are there any extra things added to the rule for overload resolution?
For overload resolution. Okay. Yeah. So so for overload resolution, if there are more than one parameters, so your question is so if there are multiple matches, which one? Yeah. So in that case, yeah. So it goes from left to right. Okay. So let me just go to the rules of the. Yeah. So yeah, so this is with one parameter. Okay. So the question is if how does overload resolution work for multiple parameters? Okay. So yeah, so you do the overload resolution from left to right. Okay. Yes.
Sir, so the viable functions, how would we identify, like suppose I'm calling a function with two parameters, which one of which is int and the other is double, and there is a function which is only having int, and there is a function which is having two parameters as int. So these two functions are viable functions.
Can you? It's difficult for me to understand. So maybe can you just type in the chat or something the function?
So viable functions are taken based on the number of parameters, right?
Viable functions are taken as the on the basis of the number of parameters. Yes.
Okay, sir.
Okay. Okay. So maybe yeah.
Yes, sir. If it is number of parameters, then my doubt is clear.
Okay. Thanks. Yeah. So yeah. Okay. Okay. So
So I have a doubt. Uh, let's say there are two functions of the same name. One has int 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 and one has double 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 as the parameters. So if I call it with double int int, it will go to double double double, right?
if you call it with double int int, no, it will go to int int int.
Sir, it
Because
So it's left to
compilation.
right.
no, but there will be two exact matches. So it's based on number of parameters. Okay, so there will be two exact matches, and there will be one. See, remember this. Okay, so this is the hierarchy. Okay, so if there is an exact match, okay, that is the best thing. Okay, so that thing will so that particular parameter will be matched. Okay, so in this case with double there is only one exact match. Okay, and with int there are two exact matches. Okay,
So it will just compare the number of exact matches, and
yeah,
whichever has more, it will go to that.
right. And at each stage this is what will happen. Okay, so if there are no exact matches, then at the promotion stage also it will compare which match has the highest number of promotions.
Okay, sir. Understood.
Okay. Okay. So yeah. So okay. So we have discussed and yeah. So I think it is clear. This is just the summary. Yeah. So I think we are running out of time also. Yeah. So any questions or comments?
Sir, the previous example that was given, won't that give an error? I think it should give an error.
Which example?
Like what Aritra said, that we should have means a function with all double and a function with, I think, first parameter as means like int double double and double double int is.
No. I think, yeah, this is why it is difficult to discuss like this. So let me just type in here. Huh? So I think so this is how I understood the question. Maybe, okay. So I'm just saying, okay, this is one definition. And this is another definition. At the time of calling, I'm calling with int double, right? I thought this was the question. Is
Yes,
this
sir. Yes, sir. It was double int int, but it's okay. I mean, it's the same, just reversed.
Then the
When I
first one
called, I
should be
was.
called.
Sir, shouldn't this result in compilation error?
Yes, sir. I'm getting a compilation error by call is ambiguous mistake.
Okay. Let us just see this. Okay. Why should this be call is ambiguous? Okay, so I have to check this. According to me, yeah, okay, I have to check this. So according to me, it should be okay. Let me check this. Okay. Yeah, maybe yeah. Let me check this, that whether this will be ambiguous or it should be based on number of matches, because it has an exact match with one and a promotion and a oh, okay. So because it has an exact match, yeah. So this one will be ambiguous, right. But if all of them are promotion, okay, yeah. So if okay, I think yeah. So yeah, so because there are two exact matches, it will say, I mean, both of these are so it no, there are no exact matches, right? So okay, let me resolve this. Okay, so let me resolve this issue a little bit further. Okay, any other questions?
Sir, could you please go to the slide where you explain the function overloading with default parameters? Yes, sir, this slide. Sir, if the function f of x was not called, would the int f int be defined then?
No. So see, these are not defined. Okay, so this.
Sir, I meant not defined. Would that be prototyped there?
No, int. See, let me put it this way. Okay, this is done implicitly by the compiler. This prototyping is never done explicitly. Okay, you can think of it that in the background, the compiler is doing this kind of a prototyping. So this happens entirely within the compiler. It's not even like a pre-processing that there is some kind of a prototype generated. Okay, this is a way to think about it.
Okay, sir. So this is not actually a piece of code that is inserted after preprocessing.
No.
Okay, sir. Okay, sir.
No, this is done inside the compiler. The compiler handles both default parameters and overload resolution.
Okay, sir.
Okay. Yeah. So this is one of the tricky topics of C++. Yeah. So yeah, one should be very careful about which particular function gets called. Okay, so we will anyway, we will continue this discussion. I mean, okay. Okay, then. Thank you very much, everyone.
Thank you, sir.
Thank you, sir. Thank you, sir.
I have posted an example of what will not work.
Okay, sir.